Today, let's explore the feasibility of planetary modification. In recent years, Mars has become the focus of attention for many people on Earth. You may have heard about various plans to go to Mars. For most ordinary people, the real challenge lies in understanding how we will achieve this feat. At present, multiple institutions have launched probes to Mars, and there are more plans in the pipeline. Mars is depicted as a popular movie subject for aliens to visit Earth. The reality is quite different. Humans are the pioneers of exploring and possibly even colonizing Mars. The main question we face today is how to achieve this goal. Once we land on Mars, how can we survive there for the long term? The atmosphere of Mars is mainly composed of carbon dioxide. The surface is extremely cold. Gravity is only 38% of Earth's. These conditions are extremely unfavorable for human survival. However, by leveraging modern advanced technologies and models, these challenges can be overcome. NASA has announced plans to send humans to Mars by 2030. Space's hopes to achieve this goal by 2024. After reaching Mars, we will explore how to establish a habitat on the red planet, growing food and meeting other survival needs. Scientists believe that the environment on Mars was very different. Conditions were once more conducive to life. There's liquid water on the surface. Some have even speculated that life might have once existed on Mars. The molten iron in the planet's core generates a powerful low magnetic field. This magnetic field once protected Mars from its solar relatives. Then Mars experienced new volcanic activity, formed an atmosphere similar to that of Earth. This allows water to circulate on the planet's surface, providing possible habitats for life. But over time, the passage of planetary core cooling, the geomagnetic field disappears, makes the surface of Mars vulnerable to strong impacts from the sun. Eventually, the atmosphere becomes desolate by the glass surface. Moisture returns to the ground, created the poverty we see today. Scientists have come up with a model for restoring Mars' magnetic field. Although this is an extremely challenging task, but if it can be achieved, it will provide important assistance in solving other problems on Mars. We can place a female star at the Lagrangian point between the Sun and Mars. To restore the magnetic field of Mars, Lagrangian points are stable points formed by the interaction of the attractive forces of the Sun and Mars. If enough magnetic force is generated here, it could provide protection for Mars. As the magnetic field recovers, the atmosphere will begin to accumulate, capture more air and heat, forming thick clouds. Provides the foundation for the formation of weather systems. It initially falls to the ground in the form of ice or frost. But as the atmosphere builds up, water will accumulate in the air, falling in the form of ice-coated fish, marks the beginning of the water cycle. Finally, we will be able to see flowing rivers and ponds on the surface of Mars. Scientists have also developed a device that uses solar energy. Through a special metal organic framework, absorb moisture from the air at a relative humidity as low as 20%. This device uses a 2-pound metal organic framework. It can extract about 3.2 liters of water from the air in 11 hours. Getting water on Mars would be a major breakthrough. Apparently, the first step to terraforming Mars is to get there. In the past few years, we've seen NASA's advances in landing technology. Now many agencies are planning to send landers and rovers to the Red Planet. Soon humans will also set foot on Mars. But getting there, then scientists will focus on studying the planet, finding viable options for long-term residence on it. NASA is already exploring different prototypes of sustainable Mars habitats. The design concept for these Mars habitats to be circular is to create a self-sustaining environment, well-sealed, an environment unaffected by the thin atmosphere. It can support long-term life support. Just as the International Space Station showed us how to survive in outer space, the Mars base will face a whole new set of challenges. In order to achieve this goal, it must be equipped with environmental control and life support systems. USS power system, joint facilities such as docking ports and airlocks. Make sure astronauts can safely conduct spacewalks to maintain and upgrade facilities. In addition, the long-term fire journey is not only a physical challenge, it can also have an impact on the mental health of the crew. Although they have received relevant training, therefore, designers should consider providing more personal space. To meet the demands observed on the International Space Station and the needs of astronauts, NASA is also exploring a unique design concept. The so-called Mars Igloo. This is an inflatable internal structure. The outer layer uses materials extracted at the Mars site and a habitable environment encased in an ice shell. The main reason for choosing ice as a building material is its excellent properties as a radiation barrier. On Mars, radiation protection is one of the most important challenges. Due to long-term exposure to radiation, astronauts may be at risk of cancer or acute radiation sickness. Although the construction of underground bases can be considered, this problem has been circumvented. Offer a more attractive solution. Allow sunlight to shine through. It avoids the blockage caused by complete degradation, due to the fact that Mars is farther from the Sun and lacks a thick atmosphere. This leaves the surface of Mars both cold and exposed to radiation. Therefore, it becomes essential to create a special habitat that can provide both warmth and breathable air. Growing food on Mars is also a major challenge. Due to the thin atmosphere and weak sunlight on Mars, make plant growth conditions more demanding. Research shows that the Martian soil contains some nutrients that plants need to grow. But between extreme cold conditions, plants need to grow in a controlled environment. Same as on Earth. The nutrient content of Martian soil may vary from region to region. Therefore, residents need to add fertilizers to enrich the soil nutrients. Recommended methods include the use of organic waste or fertilizers. It is worth mentioning that the atmosphere of Mars is mainly composed of carbon dioxide, exactly what plants need for photosynthesis. The low-gravity environment of Mars also means that plants may require less water than on Earth. Because water flows through Martian soil differently than it does on Earth. NASA's collaboration with the University of Arizona, one developed is called a bioregenerative life support system. BLSS's advanced own planting facility. This is a hydroponic growth potential, growing food without soil. There are higher plants, artificial ecosystems formed by complex symbiotic relationships between animals and microorganisms. This system provides a nutrient-rich hydroponic environment for plants. And plants contribute oxygen to the environment through photosynthesis. It creates a mutually beneficial ecosystem. Although we have great hopes for the future of Mars, imagine plant greenhouses and human civilization built with modern technology. But it will still take time to achieve this goal. Scientists and astronauts' first missions will focus on understanding the planet. Learn the skills to survive in an environment very different from Earth's. The original Mars base may combine living modules and science laboratories. The interior design of these facilities is similar to that of space exhibitions. But it will also be unique. Microbes do represent an unknown threat in space exploration. There's not enough research. Scientists find it difficult to determine whether there are microbes that could harm human life. Once Mars and Earth are established, astronauts acquire the skills they need to survive. The exploration will enter a deeper stage. Then people will start to focus on how to use Mars's resources and necessities to achieve self-sufficiency. As time goes by, farming and water accumulation activities will be gradually launched. Scientists will attempt to make Mars suitable for sustainable life through these efforts. Currently, space exploration enthusiasts like Elon Musk are working to make Mars a permanent place for humanity. Colony aims to deliver about 250,000 people to Mars and establish a colony there. In the coming years, we expect to see the first humans landing on Mars. Soon after, the establishment of a colony on Mars, with technological advancements and changes, the future of space exploration is bright. The exploration of Venus. Although this planet is closer to the Earth, and it was once thought that it might have existed as life, but it diminishes people's interest due to its extreme environmental conditions. Since the mid-1990s, although nearly 30 proposals for Venus exploration submitted to NASA were not approved. But recently there has been a resurgence of interest in Venus, especially after finding controversial evidence of Lin-Hua-King in the atmosphere. Now more and more planetary scientists are beginning to hypothesize that Venus may be suitable for terraforming Venus. Maybe even more than Mars. Until about 7 years ago, Venus was once a warm, wet planet. 80% of its surface is covered by oceans. However, about 500 million years ago, a global resurface event led to the release of large amounts of carbon dioxide into the atmosphere. It blocks the possibility of carbon dioxide from the atmosphere being absorbed by the Earth's crust. And it causes the runaway greenhouse effect. That made Venus the hostile environment it is today. If we can reverse this greenhouse effect, humans may get a little closer. Planets similar in size, mass, and gravity to Earth. Venus is the closest planet to Earth. Its minimum distance is approximately 38.2 million kilometers. Maximum distance is approximately 261 million kilometers. Due to the orbital properties of Earth and Venus, every 584 days, that's about a year and 7 months. The Earth and the Golden Star are the closest to each other. This phenomenon is known as the Summer River. In comparison, the average distance between Earth and Mars is approximately 2.251 kilometers. That distance varies from 55.7 million to 401.30 million kilometers. Our two neighboring planets move about every 26 months, and 2 years and 2 months to approach the minimum distance. This is called an opposition. because when viewed from the Earth, the Sun and Mars are located on opposite sides of the sky. Therefore, compared to Mars, Venus is not just closer to Earth. We're getting closer. This means that missions to Venus could be launched more frequently. It also requires less star time. The gravity of Venus is close to 90% of that of Earth. And this is remarkable. In comparison, the gravity of Mars is only about 38% of that of Earth. This means it is possible to establish habitats on these planets in the future. For the people who live there, the health risks of a low-gravity environment are much lower on Venus. However, Venus' environment is full of challenges. This makes it extremely difficult to survive on its surface. If humans wish to settle there on a large scale, planetary terraforming is not just a good idea. In fact, it has also become a necessity. Venus is the hottest planet in the solar system. Its average surface temperature is as high as 464 degrees Celsius, enough to melt metals like lead and stars. The atmosphere of Venus is saturated with toxic carbon dioxide and a small amount of nitrogen, sulfur dioxide, and water vapor. Unlike Mars, the atmospheric pressure on Venus is 90 times that of Earth. To experience the same stress on Earth, need to dive more than 9-10 meters deep in the ocean. So unless you have equipment that can withstand extreme heat and pressure, otherwise, it is impossible to approach the surface of Venus. Go one step further. Venus's atmosphere is also filled with sulfuric acid rain clouds. These sulfuric acid rain clouds have been observed in the upper atmosphere of Venus. They may not condense close to the ground, but any spacecraft attempting to land must first pass through this acidic cloud. Venus rotates at the slowest speed of any known major planet. It takes about 243 Earthlings to rotate, and it rotates in a different direction than most planets. In a counterclockwise direction, this is a phenomenon that astronomers have only observed on Venus and Uranus. Because Venus is slowly retrograde, it takes about 225 Earth days for a tile to orbit the Sun. One day on Venus is equivalent to 116.75 days on Earth. This means that observers on the surface of Venus will experience almost 4 months to see the Sun rise and set again. Venus is almost isothermal. Its temperature hardly changes. This is because of its dense atmosphere, due to the slow rotation speed and small axial tilt. Almost means that there are no seasonal changes or day-night cycles as we know them on Venus. So Venus might sound very hostile. It's like coming out of hell. But with the right ecological technologies and efforts, Venus has the potential to transform the cup into a warm and pleasant one, a beautiful planet with endless coastlines. Same as Mars transformation. The goal of careful retrofitting can be reduced to 3 main directions: reducing atmospheric pressure, reduce surface temperature, and converting the atmosphere into a gas that humans can breathe, like the complementarity of targets during the Mars reinvention process. Although these goals may seem ambitious and challenging, fortunately, Venus has enough resources. The result of its modification may make it easier for humans to adapt. The first proposed method for transforming Venus into an interior planet was proposed by Carl Sagan in 1961. He proposed in a paper on Venus, by introducing genetically modified cyanobacteria into the atmosphere of Venus, it can gradually convert carbon dioxide into organic molecules. However, Later discoveries of sulfuric acid in the atmosphere of Venus and the influence of the solar wind on Venus makes Sagan's proposal seem less credible. 30 years later, in his 1991 research paper, Paul Birch of the United Kingdom, a new method for rapidly geographing gold forms is proposed. Birch thinks injecting large amounts of hydrogen into the atmosphere of Venus can trigger a series of chemical reactions. Produces graphite and water by separating the graphite and let the resulting water fall in the form of fish water, could cover 80% of the surface of Venus. Birch also proposed using sunshades to reduce the global temperature of Venus. This is the solution he and renowned aerospace engineer Robert Zubrin recommended. They are considering deploying a series of satellites in the atmosphere of Venus to reflect sunlight in space, or deploy giant sun visors at the Lagrangian point between the Sun and Venus. To reduce the amount of sunlight reaching Venus, this would not only lower the temperature of Venus, it also protects its atmosphere from solar wind erosion. Another proposal is to accelerate the rotation of Venus. This could not only help create an Earth-like day and night cycle, it also helps to reduce the impact of Venus's dense atmosphere. Methods to increase the rotation speed include using large green and small green to hit the surface of Venus, or use new gold technology massless drives to transfer kinetic energy to the surface of Venus. By this means, the atmosphere of Venus could become thinner. Environment closer to the Earth. The final face of Venus will be a planet primarily covered by oceans. The surface is basically made up of islands large and small. It also includes some larger land masses. As time goes by, plants can be introduced, trees, bacteria, and aquatic organisms. Promote the diversity of life and the prosperity of ecosystems. Although the camera that will be transformed into an interior planet is full of appeal, but the effort required to achieve this goal, the time and resources are tremendous, except for Venus and Earth in size. Phase magnetism in mass and composition, extreme environmental conditions, atmosphere of high temperature and pressure, are major challenges in the implementation of the terraforming process. For example, lowering the temperature and pressure of Venus requires a huge energy investment, and infrastructure buildings that are difficult to achieve under current infrastructure conditions create an orbiting sunshade large enough to lower the surface temperature of Venus. It could be 4 times the size of Venus, and it needs to be assembled in space. This poses a major challenge to current technologies and resources. Increasing the rotation speed of Venus also requires tremendous energy and resources. It may be necessary to guide large impactors from the outer solar system, mainly using resources from deliberate efforts. In the process, we need a large number of spaceships to transport the necessary materials, and they have to have efficient propulsion systems. To ensure that the journey is completed within an acceptable time, however, such an efficient propulsion system has not yet been developed. And traditional propulsion technology, from ion propulsion to chemical propulsion, not fast enough. The cost is also too high. For example, NASA's new NORO probe is powered by conventional rocket technology and Earth's gravity. It took more than 11 years to make a historic close flyby of Pluto in the Kuiper Belt. Again, Liming Howe detector that relies on plumb propulsion. It also took nearly 4 years to reach the asteroid's amorphous star. These two methods are suitable for frequent round trips to and from science and technology, impractical for transporting cold comets and asteroids. And we still lack a sufficient number of spacecraft to perform such a mission. The idea of placing solar reflectors above the clouds of Venus faces similar resource challenges. Since the surface of Venus is completely covered by clouds, the mass required is tremendous and must remain in place for a long time after the atmosphere changes. And Venus's clouds are already highly reflective. Any change would require a significant increase in its existing reflectivity of 0.65 to be effective. The idea of removing Venus's atmosphere is equally challenging. In 1994, calculations by James Pollock and Carl Sagan revealed that even a 700-kilometer diameter impactor hitting Venus at extremely high speeds, the loss of its atmosphere is less than 1/1000 of the total. And here's the thing. As the density of the atmosphere decreases, the effect will gradually decrease. That means thousands of these giant loading machines. In addition, most of the ejected atmosphere may enter the orbit near Venus and recaptured by the attractive forces of Venus without further intervention, become part of the atmosphere. Removing gases from the atmosphere through a space elevator will face tremendous difficulties, because the altitude required to achieve an orbit of the Earth's diameter is impractical. Removing the gas using mass accelerators is time-consuming and expensive. In general, the potential benefits of terraforming Venus are obvious. Humanity will have a second home. We can channel its resources into our resource suffering and learn valuable techniques to prevent catastrophic changes to the planet. The challenge, however, is to realize these benefits, as is the case with most proposed landscape improvement projects. Numerous obstacles need to be addressed beforehand. The most important of these include transportation and logistics issues. Mobilize a large number of robots, workers, and transportation to gather the necessary resources. What will follow will require a multi-generational commitment and sustained investment of financial resources. Even under the most favorable circumstances, it's not going to be easy. It can be said that in the short term, this is an almost impossible task for humans. However, turning Venus into a planet with oceans, the sister planet of cultivated land, wildlife, and cities, someday in the future, it's a beautiful and achievable goal. Here's the thing. How long do we need to wait? And for the possibility of terraforming the moon, although we often hear about improving the camera of Mars, we rarely hear much talk about the moon. Conventional thinking holds that bombard Mars with a water-filled pop, turn its surface blue, then it turns green. Seems like a simple character. But what about the real situation? What measures can we take to transform the moon? Is this really possible? Let's find out. Compared to any other star in the solar system, the significant advantage of terraforming the moon is its location in forbidden areas. Compared to Mars or Venus, we can almost walk with a man on the moon at all times. This greatly facilitated the logistical support of the mission. However, not all aspects are favorable, because every planet or moon is unique. To survive anywhere in the universe, we all need to meet some basic needs: food, water, breathable air, and radiation shelters. That means we need, first of all, an atmosphere. The moon has no atmosphere in principle, because any gas that might be there will eventually be blown away by the solar wind. The first problem to be solved is that the moon lacks a magnetic field. No magnetic field? Any attempt to build an atmosphere will be carried away by the solar wind. Due to the moon's small size and lack of active geological formations, activating or reactivating the lunar core's dynamo doesn't seem like a viable option. One alternative is to install a powerful magnetic field generator. To keep it in orbit around the moon, this device can be placed at the first Lagrangian point. This is a place where the attractive forces of the ladders cancel each other out. An object at this point can maintain a fixed position in space. Compared to other celestial bodies such as the moon and the Earth, this device consumes a lot of energy. However, large solar panels can provide the required energy. And it's much more efficient in the absence of an atmosphere. At the same time, mirrors are deployed at this point to concentrate solar energy on the lunar surface. The various activities carried out on or under the lunar surface provide abundant energy. In addition, it also helps to improve the quality of human life. Due to the long-term negative effects of solar wind and related radiation on astronaut health, it might even promote cancer. Next, consider water. Atmospheric and temperature issues. Once the solar wind and radiation are no longer an issue, we can put this hand dirt into the lunar atmosphere and transport water to the moon. It should be pointed out that bringing water to the moon by meteorite impact may be a bad idea. Although it is theoretically possible to control popular impacts that carry moisture or other desired substances. But go to shocking new generation. And the logistics of accurately transporting a meteor to the moon is not only expensive, it's also very inefficient. We need a faster solution. If the calculation is incorrect or certain factors are taken into account when simulating the lunar impact trajectory, with this undesirable impact, the gas may be released. Water and other matter are ejected into space, cause loss of atmospheric gain in time. Not to mention the possible risks to human life. Therefore, exploring the moon's own resources may be a better option. Studies over the past few decades have shown that ice water exists on the lunar surface, especially in places where sunlight cannot reach. A cloudstone crater or shaded area formed by rocks. In addition, planetary geologist Alexander Basilev of the Russian Academy of Sciences mentioned that moon rocks collected from the Apollo missions contain water, so we can extract water from these rocks. Suppose we could use solar panels and burners, efficiently harness solar energy. In this context, we can harness this energy, breaking down lunar rocks through electrolysis. The gradual extraction of existing elements from the lunar surface. The latest lunar geology shows the same map. The U.S. Geological Survey has partnered with NASA to reveal how rich the lunar surface is in silicates. So getting oxygen from the moon is not a big problem. If rocks in the moon's branching layers are rich in oxygen, we can use the hydrogen in space to produce water. This is exactly what the driver Alexander Bakiliev described for the formation of water on the moon. However, this moisture is volatile. It is easy to escape into space when bombarded by the sun's energetic particles again, splitting water molecules into clear and oxygen, unless they can find shelter in the moon's craters and permanently shadowed regions. People think that going from 2 levels to the equator, the moon may have ice. This provides us with a precious resource that is relatively easy to access. At the same time, The electrolysis process necessarily generates heat. Therefore, while generating or trapping oxygen in water, we can release heat slowly and safely. Given that we're already experiencing a warming of the planet, one of the current challenges is the amount of eggs and carbon detected in lunar rocks is very low. And these two elements are essential for life. It's extremely rare on the moon. However, this may not be entirely accurate, because the samples we have don't cover the entire moon. There may be places where rock deposits do contain these elements. Since the detection of carbon ion sample emissions, this assumption is being further strengthened. According to data from the Japanese lunar orbiter, the GLOW Night mission, it was found that the number of basalt plains was higher than that of the first period. If the carbon part of this discovery is confirmed, then he also gives us hope of finding the egg. Or it could be possible to promote material recycling by adding smaller amounts of elements to the lunar atmosphere. The problem with gravity. One of the main challenges in terraforming asteroids and moons is their low gravity. People often fantasize about having satisfactory water surfaces and waves up to 20 meters high on the moon. Because there's less gravity, people can fly easily, as if the moon were the moon Florida. But for now, it's still just an illusion. Well, actually, the first force environment has two big problems. First, it affects the health of settlers or future residents. Many astronauts have experienced first gravity conditions on the International Space Station or other space trips. Although the gravity of the moon is only 1/6 that of the Earth, but it's better than nothing. The loss of bone and muscle may not be as significant as it is on Earth. Despite this, we can do that by adding weight to the suit, such as adding chips to simultaneously increase weight and protect against radiation. Or reduce this problem with lots of exercise and special exercise and sleep facilities. Simulate the gravitational conditions of the Earth. During the terraforming process, the problem of gravity is even more serious, because it, along with the solar peak, prevented the moon from retaining the atmosphere we were trying to build. It is estimated that we can maintain the atmosphere for about 10,000 years. This forced us to either build a giant dome to keep them, either continuously generating new gas to replace the gas escaping into space. This is a far cry from the original intention of terraforming the moon. On the other hand, continue to use meteors. The idea of asteroids and comets attacking the moon to increase its mass to better preserve its atmosphere. Not only does it increase the above risks, and it's probably not such a good idea for life. If the mass of our satellites keeps increasing, he will be able to attract more meteors and asteroids. In addition, tidal effects can be devastating, affect the lives of many coastal residents, and could have a significant impact on the value chain of energy infrastructure. Therefore, if we can't increase the mass of the moon, and the atmosphere is inevitably lost, so terraforming the moon with current technology doesn't seem feasible. But that doesn't mean we should give up. In exploring the theoretical challenges of lunar environmental modification, researchers are finding more and more compelling elements from a scientific and economic perspective. The moon itself may hold more secrets for us to uncover. It is worth noting that the original intention of the Apollo missions was more political. Rather than scientific exploration, this led to the choice of landing sites at that time not fully taking into account the advantages of scientific research. Therefore, it is particularly important to have a deep understanding of the resources held by the Moon. NASA-led Artemis program. Collaborating with multiple space agencies, aims to return to the Moon for great exploration. Test the various experiments and commercial layouts proposed so far. Suppose we have established the logistical knowledge system for extracting lunar resources and discovered mineral resources of economic value, such as rare earth elements, then this plan will be accelerated. And it may inspire competition, launching a new era of space mining. Under this premise, the establishment of industrial bases and human settlements to operate these industries will be a top priority. We will apply all the knowledge we have learned to achieve this goal. Possible plans include building domed structures inside large craters, utilize water resources, and introduce the soil of a specific area, carbon and eggs to support workers' living needs. Solar panels and solar ovens will provide the necessary energy. In addition, lunar mining will also involve electrolysis processes, due to the fact that daylight on the Moon can last for weeks. Another way to provide shelter for humans is to excavate caves in the back room of the excavator. These caves can be maintained naturally during the day. Indicates the temperature of human habitation. We can use the energy accumulated during the day and night. Such activities are likely to expand gradually. Eventually make lunar colonization an indisputable implementation. In addition to the financial benefits, this colonization had other benefits as well. For example, the Moon could serve as a space operation base for other satellites and planets. It benefits from lower gravity. Launch costs will be greatly reduced, driven by economic demand. The necessary infrastructure will be gradually established. Well, in theory, this makes the above proposal even more attractive. If we continue to use existing technologies, the local resources of the Moon, especially water resources, it will assist in the production of rocket fuel. At the same time, Mercury is very similar to the Moon in many ways, but it has more attractive forces and more abundant energy supplies. On Mercury, we can apply the same techniques that were explored on the Moon, and it has great potential for terraforming. The experience of working on lunar environmental modification will open the door to other similar satellite environmental modifications. The solar wind and gravity are more conducive to this mission. This further expands the possibilities of space mining. We may not be able to terraform every object in our solar system yet. One-way progress towards this goal would be one of the greatest achievements in human history. Ultimately, humanity will take a major step in the right direction towards becoming a space-colonizing race. Although we should remain vigilant against any moral and social issues. But until man-made habitats become self-sufficient, lunar colonization is essential to our survival. It also marks the natural course of the development of our species.